Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 9th, 2025, just yesterday. It shows that a web-native renderer can unify WebGPU and ONNX-based neural inference right in the browser, delivering up to about 135 times faster end-to-end 3D Gaussian Splatting rendering compared with existing web viewers. The paper is titled Visionary, the World Model Carrier Built on WebGPU-Powered Gaussian Splatting Platform. And, as we will see later, the combination of real-time performance and plug-and-play generative models has exciting implications for how world models get deployed online. Also, the author shared a GitHub repo for Visionary. There you'll find the full web GPU-based renderer, TypeScript source, demo scenes, example 3 DGS and mesh assets, plus scripts for ONNX export. The README walks you through quick setup, running browser demos, and plugging in your own Gaussian splatting or avatar models. Figure 1 shows that Visionary runs as a browser-based editor, where many different asset types coexist in one scene. The main canvas in the middle packs all these models together, demonstrating simultaneous rendering on WebGPU. On the left, the scene manager lists each loaded model so users can toggle or reorganize content. In the center, the dinosaur labeled 4DGS illustrates time-varying Gaussian splatting, which means Gaussians can change over time to capture motion. Around it, avatars, classic 3D Gaussian splatting objects, traditional meshes, and an MLP-based 3D Gaussian splatting building highlight how heterogeneous assets all share the same runtime. Figure 2 explains how Visionary turns many different neural scene formats into one rendered and optionally stylized frame. The left block shows various 3D Gaussian splatting variants feeding into ONNX, which is a common model format that lets different neural networks run in the same runtime. The center WebGPU block then sorts and composites Gaussians with classic mesh rendering, so everything shares one depth-aware pass. The right block runs ONNX-based generative models on the intermediate frame, using prompts, if desired, to produce the final output that applications access through 3JS. This table shows that Visionary keeps image quality at least as good as Spark.js, despite its massive speedup. The comparison uses the MIP-NERF 360 dataset and reports three standard metrics: peak signal-to-noise ratio, structural similarity, and LPIPS, which measures perceptual difference between images. Visionary scores slightly higher on peak signal-to-noise ratio and structural similarity, so reconstructions look cleaner and more consistent. It also achieves a slightly lower LPIPS value, which means renderings appear a bit closer to the ground truth, to human perception. Table 1 shows that Visionary slashes frame time, mainly by moving the expensive sorting step from the CPU to the GPU. The table body compares Spark.js on the left, with Visionary on the right across different numbers of Gaussians. For every scene scale, Spark.js spends tens to hundreds of milliseconds on sorting, while Visionary keeps sorting under 1 millisecond. The preparation and drawing times are also lower, so total frame latency drops from about 177 milliseconds to roughly 2 milliseconds at full resolution. Alright, to wrap up, the key message is that a browser can now host full world models. Visionary unifies ONNX neural inference with WebGPU rendering to deliver real-time 3D Gaussian splatting and avatars at scale. This lowers deployment friction and opens the door to interactive generative 3D on everyday devices. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.